4.5 billion years ago, the sun, its planets, and their moons formed out of a great condensing cloud of dust and gas. But not all the material in this cloud was used up in these formations. What was left formed the minor members of our solar system. Comets shine mainly because the sun causes gases they contain to glow like a fluorescent light. Friction with the air causes the glow of meteors as meteoroids plunge into our atmosphere from space. Asteroids shine from light reflected from the sun. Light, however it is produced, can give us information. Astronomers use telescopes to gather the light reflected or produced by comets, meteors, and asteroids. To get information about their composition, astronomers use a spectroscope that spreads this light into a spectrum of colors. Astronomers can also use radio telescopes to study meteors. Radar waves broadcast toward meteors bounce off them. These echoes can be recorded as photographs for study. Probes have been sent on journeys into deep space to return information about the size, composition, and movement of the minor members of our solar system. Asteroids are planet-like bodies and have often been called planetoids for that reason. They follow generally circular orbits around the sun, like the planets, in a wide region that lies between the orbits of Mars and Jupiter, the asteroid belt. Only about 3,000 have been charted and named. All are relatively small. Only one asteroid is barely visible to the naked eye. The rest require telescopes for us to see. When a telescope is used to photograph the asteroids, clockwork moves the telescope to follow the background stars across the sky. When the film is exposed for several hours, the stars produce bright, round images. But the asteroids, moving in their orbits, produce elongated images called trails. This is the trail of the asteroid Eros. Eros sometimes comes within 15 million miles of Earth, not far as cosmic distances go. Asteroids tend to collect in groups called families, probably because of the gravitational influence of Jupiter. Jupiter's strong gravity may also be the reason for many asteroids, rather than a single planet between the orbits of Mars and Jupiter. As all the other planets were forming, Jupiter's great mass could have disturbed the orbits of the asteroids. Instead of coming together to form a single planet, they spread out and maintained their independent orbits. Perhaps several bodies, the size of the largest of the asteroids, formed originally. But in the course of thousands of millions of years, collisions produced many smaller fragments. From such a series of collisions, the thousands of small asteroids that exist today may have been formed. These bits of asteroidal debris may also be responsible for another kind of interplanetary wanderers that we sometimes see flashing above us in the night sky. These are the meteors. Although they're often called shooting stars, they're, of course, not stars at all. Most often, meteors are caused by tiny particles not much larger than grains of sand. These meteoroids blaze into hot, luminous gas. Most of the tiny meteoroids that become meteors are destroyed in their fiery collision with the Earth's atmosphere. But occasionally, when a meteoroid is large, it will not be totally consumed by friction, and it will reach the ground. Then it is called a meteorite. The fall of large meteorites can produce craters. This meteor crater in Arizona is more than 1 kilometer wide. It's rare to find meteoric craters on the Earth. Erosion from wind and water wears them down. Most craters on the moon were formed in the same way, but have remained with little change because there is no atmosphere. as there is on Earth. Only a few large meteorites survive the fall to Earth each year. They usually find their ways into museums. Most are of just three types. There are stony meteorites. These are pretty much like ordinary rocks. Metallic or iron meteorites are mainly composed of iron and nickel. And a few meteorites are a combination of the rocky and metallic types. There is one rare kind of meteorite that contains compounds of carbon. Most examples of this kind of meteorite have been found in the frigid regions of Antarctica. These carbonaceous chondrites, as they're called, fall all over the world, but quickly disintegrate when they land on the ground. But those that have come to Earth here in the Antarctic become buried in the snow and ice and remain preserved for hundreds and thousands of years. Movement of Antarctic ice eventually brings the meteorites toward the surface. And as top ice evaporates, meteorites are left behind, black against the Antarctic whiteness, easy to be found by interested scientists. Carbonaceous chondrites are unusual in that they contain organic substances, carbon compounds that are found in living things. These meteorites raise questions about the origin of life in the universe and whether there is life beyond Earth. Very few meteoroids actually reach the surface of the Earth. Most are destroyed as they plunge into the Earth's blanket of air. 100 million enter our atmosphere each day. Such micrometeorites that can pit space vehicles have been collected on the paddle arms of devices like this one. In space, the capsule opens, exposing its paddle arms to the micrometeorites. Recovered on Earth, the capsules have brought back evidence that the Earth is surrounded by a vast cloud of these tiny particles. Periodically, the Earth's orbit carries it through thick swarms of meteoroids, resulting in meteor showers. This, with perhaps a little exaggeration, records a spectacular shower that took place in 1833. The explanation for meteor showers that recur yearly or in longer periods can be found in a third type of wanderer between the planets, comets. A comet is composed of an enormous spherical head of gas and dust that is usually many thousands of miles in diameter. Streaming out from the head is an immense tail, often millions of miles long. The source of a comet's tail is material in its head. Within the large head is a much smaller, sharply outlined nucleus. The nucleus is a mass of frozen gases and meteoric material a few miles in diameter. As the comet approaches the sun, it is heated by sunlight. This heating thaws the solidified gases near the surface of the nucleus and also releases some of the meteoric material. The gases absorb energy from the sunlight and glow. Pushed away from the nucleus by the light pressure and the electrified particles from the sun that we call the solar wind, the continuing flow of dust and gases forms the long tail of the comet. The tail will gradually be lost as the comet moves away from the heat of the sun and material stops flowing from the nucleus. Some comets travel around the sun in periods of less than 100 years, while others come past only once in thousands of years. And where do they come from? Perhaps from a vast storehouse of comets at the very fringes of the solar system, matter left over from its formation. This cloud of comets may be 40,000 times as far from the sun as Earth is. But dislodged by gravitational interactions from passing stars, an occasional comet may be nudged out of this cloud and begin a long, slow fall toward the sun. Halley's comet is one of the best known. It makes an orbit around the sun about once every 76 years. Halley's comet moves through the solar system in a direction opposite the direction in which the planets move. Its orbit, like those of most comets, takes it far out of the narrow region of space the planets travel through. The comet's elliptical orbit carries it from a distance farther out than Neptune, 30 times as far from the sun as Earth is, to a point in space within the orbit of Venus. Halley's was the first comet whose return was predicted, although its appearance had been recorded many times throughout history. When it passed Earth in 1910, its tail grew to be more than 100 million miles long. Earth actually passed through the comet's tail that year. Halley's comet returned to the vicinity of Earth in 1985. After it had rounded the sun in March of 1986, 5 space probes rendezvoused with the comet, carrying instruments to electronically observe its nucleus, measure its size and electromagnetic properties, sample its dust and gases. This computer-enhanced photo, taken by a camera on one of the probes, shows an irregularly shaped nucleus, a large lump with a smaller lump attached. It is about 14 by 7 kilometers in size, some 10 miles long and 5 miles wide. The surface of the nucleus is rough, covered with craters. The nucleus rotates once in about 2 days. The probes found that clouds of dust surround the nucleus, that it's covered with a thin layer of an intensely black substance. There is a strong outflow of dust particles from it in the form of narrow jets. These particles seem similar in composition to the carbonaceous chondrite meteorites found in the Antarctic. The contact between the probes and Halley's comet was brief. Halley's comet will not return until the year 2061. In the process of developing tails and losing them, comets seem to release swarms of meteoric materials that follow along the same orbits. In time, a swarm may lag behind or move ahead of the parent comet and gradually spread out around the full orbit. Eventually, a comet will disintegrate into such swarms of small particles. It is these particles that are believed to produce the periodic meteor showers. But there is speculation that comets have produced more significant events on Earth. That at intervals of about 26 million years, so many comets are dislodged from their parent cloud that some actually crash into the Earth and cause disruptions of life, like the extinction of the dinosaurs some 65 million years ago. But whether comets actually wiped out the dinosaurs, Earth will always be a vulnerable target of the debris from the solar system's formation: comets, meteors, and asteroids.